Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to determine how much of a particular substance you have in a mixture of substances. When you're told that the substance or the mixture reacts in a certain way to produce a product that you are given the amount of. So let's get into this. Okay, so here's the problem. It looks like it looks kind of difficult, and it is kind of difficult, but I'll walk you through how to solve these type of problems. So here you have a 1.00 gram mixture of copper 1 oxide and copper 2 oxide, and this was reduced quantitatively by hydrogen gas to give you 0.8390 grams of metallic copper. What is the mass of copper 1 oxide in the original 1.00 gram sample? Okay, so this typical problem, you're given a mixture, you react the mixture of substances to give you a product, and then they want you to use that information to go back and figure out what was the mixture made out of, how much of each substance was the mixture made out of. And so when you do this problem, you're more likely than not going to have to do a system of equations. So let me show you what I mean. So we know that the total amount of copper 1 oxide and the copper 2 oxide together have a 1.00 gram mass. So we can write that as an equation. So we have copper 1 oxide, which is going to be Cu2O. And then we have copper 2 oxide, which is CuO. So both of these together should mass in the original mixture should have a mass of 1.000 grams. And so what I'm going to do here is I'm going to make this equal to X. The mass of your copper 1 oxide is X. The mass of your copper 2 oxide is Y. So if we write this as an equation, it'd be X plus Y is equal to 1.000 grams. So that is one equation. But notice we have two unknowns. We have X and Y. The mass of the copper 1 oxide and the mass of the copper 2 oxide. We don't know what those are. We have to find those. But as you might already know, if you have two unknowns and only one equation, that's impossible to solve. We need a second equation. So for every unknown you have to have that many equations in order to solve it using a system of equations where you do substitution and all that stuff. So where are we going to get this second equation? Well, we need the balanced equations from our reactions, and then we can do stoichiometry. So let me show you what I'm talking about. So we're told that both copper 1 oxide and copper 2 oxide were reduced quantitatively by hydrogen to produce what? Metallic copper. So let's write that out. So we'll take this copper 1 oxide, so Cu2O, was reduced by hydrogen, H2 gas. So we'll put H2, and that's going to produce, well, copper metal is one of the products, but what's the other product? So if I have copper metal, then where did the oxygen go? Well, the oxygen reacts with hydrogen. Hydrogen and oxygen react to form water, H2O. And so we need to balance the equation. So we have 2 coppers here. We should have 2 coppers here. We have 1 oxygen, 2 hydrogens, 2 hydrogens, so it's balanced. So here's our first balanced equation for this reaction. Well, what about the reaction with copper 2 oxide? We could do the same thing. So copper 2 oxide plus H2 gas gives us, again, copper metal, and it's going to give us water again, H2O. So we have one copper, one oxygen, two hydrogen, two hydrogen. So it's already balanced. So we have our two balanced equations. Now we can use these to do stoichiometry. Oops, hold on a second. Sorry about that. So as I was saying, we can do stoichiometry now. And that's where we're going to get our second equation. So what we need to find is a relationship between the mass that were provided for each of our substances. So here we have the copper 1 oxide. The mass of copper 1 oxide is going to give us a certain mass of the copper. So if I can write an expression relating the mass of this to the mass of copper formed from this, as well as the mass of this related to the mass of copper formed from this, then I can put it together in an equation. So basically, I'm going to do stoichiometry. So when I do stoichiometry here, I take the amount of the copper 1 oxide that I have, and I'm going to do stoichiometry through conversion factors to get to the mass of the copper produced. So all I'm going to do is set up the conversion process just like I normally would, but starting with an X amount of copper 1 oxide. So let me just show you what I'm talking about. So normally I would get, if I knew how much copper 1 oxide I had, I could use that to start with and then do the conversions until I got to the amount of copper that would come from that amount of copper 1 oxide. So that amount is going to be X. So I have X number of grams of Cu2O. And all I'm going to do is convert until I get to copper. So I'm going to convert grams of Cu2O to moles. I need to use the molar mass. So when I calculate the molar mass, I get 143.0919. So 143.0919 grams of Cu2O, and over that is going to be 1 mole of Cu2O. So grams cancels out. So now I have moles. I want to get to moles of copper, so now I'm going to use the mole ratio. So that's going to be my next conversion. So what's the mole ratio between Cu2O and copper? It's going to be 1 to 2. So since I have 1 mole of Cu2O here, I'm going to put 1 mole, 1 because I have here 1 mole of Cu2O. But here I have 2 moles, so that's going to be 2 moles of Cu. So moles of Cu2O cancel out, but I want grams because remember here they gave me the total mass of copper formed from the mixture is this here. So if I'm going to use this, I need to convert this to grams. So I'm going to use the molar mass of copper. When I look that up, I get 63.546. So 63.456. Let me double check that. 546, not 456. 546. 546 grams of copper on the top and 1 mole of copper on the bottom. So then this cancels out. And so now I have basically, if I was to do this calculation, my answer would end up being grams of copper. Well, how many grams of copper? Well, it would depend on the number X that I'm starting with. So when I calculate this out, I'm going to get an X amount of grams. I'm going to get an amount of copper in terms of grams and X, right? So when I multiply this out, I get 0.88818. So I get 0.88818 times X number of grams of copper. So that's what I get when I calculate all this out, and I have the X there. So this X is multiplied by everything else. So I get 0.88818 times whatever X is, grams of copper. So if I start with X grams of copper 1 oxide, I'm going to end up with 0.88818 times X grams of copper. So the grams of copper is going to depend on how many grams of the X grams of copper 1 oxide that I start with. I don't know that, so there's the X. And I can do the exact same thing with Y, with the copper 2 oxide, right? So all I do is I do the same conversions to find out how many grams of copper would have been formed from a Y amount of copper 2 oxide, or copper oxide, or copper 1 oxide. And we said that that's Y. So here I'm going to start with a Y number of grams because that's what I've got here. So Y number of grams of CuO over 1. I'm going to multiply that by the molar mass. So because I want to convert this to moles. So if I look at the molar mass, it's 79.5459. So 79.5459 grams of CuO. On the bottom, 1 mole of CuO on top. So grams of CuO cancel out. Now I have moles. Now I'm going to use the mole ratio between CuO and Cu. Here it's 1 to 1. So now I'm going to do a 1 to 1 conversion factor. So 1 mole of CuO on the bottom and 1 mole of Cu on top. So moles of CuO cancel out. And again, I'm going to convert that to grams because I want to know the number of grams that are produced from Y grams of CuO. So I'm going to use the molar mass again. So same here. So 1 mole of copper over 63.546 grams of copper. So moles of copper cancel out. So now, since I have grams of copper, all I need to do again is multiply Y times 1 times 1 times 63.546 divided by 79.5459 divided by 1, right? So I multiply all this together and I end up with an amount of copper in terms of Y. And when I do that, all of that is equal to 0.79885. So 0.79885, and that's times Y, and that's going to be grams of copper. So what I've done here, just to recap, is I've used stoichiometry. I know in my original mixture here, right, that Y, the number of grams X plus the number of grams Y equals a total of 1.000 grams total. So why? Because I made the mass in the mixture of copper 1 oxide X, and I made the mass of the mixture of copper 2 oxide Y, and I know that both of these added together gives me this. Okay, so I also know that the copper 1 oxide and the copper 2 oxide reacted with hydrogen to form copper metal, right? So I use stoichiometry. So if I could get a relationship, I know here they're giving me 0.8390 grams total. So the total amount of copper that came from Cu2O plus the total amount of copper that came from CuO, both of those added together gives me 0.8390 grams. Well, if I could get that in terms of x and y, I would have another equation. But look what I did here. So I used stoichiometry to take an x number of grams of my copper 2O, my copper 1 oxide, my Cu2O, and converted it to number of grams in terms of x. So this and x grams of Cu2O gives me this many grams of copper with x in the formula. A y grams of CuO, when I convert it to copper, gives me this many grams in terms of y of copper. Now, I have these 2 grams of copper with x and y. I know that these two added together gives me this. So there's my second equation. Let me write it up here. So 0.88818 times x plus 0.79885 y times y equals 0.8390 grams. So there's my second equation. So here's my first equation, and here's my second equation. So I know that the amount of copper 1 oxide and copper 2 oxide added together gives me 1.000 grams. That's one equation. And I know that the amount of copper in terms of x that came from my copper 1 oxide and the amount of copper in terms of y that came from my copper 2 oxide, both of these added together gives me 0.8390. Now that I have my two equations, I can solve for both unknowns. So let's go ahead and do that. So now what I need to do is I'm going to erase this to give myself some room. And let me double check to see if I need, nope. So I can erase this because it has served its purpose. And so now I can solve these two equations. Okay, so now what I'm going to do is I need to solve one of these equations for x or y and then substitute that into here. And let's just see. Okay. So I'm going to solve for x. So in this case, I have x is equal to 1.000 grams minus y. So I solved this equation for x. So I just subtracted y from both sides, and I get this. Now that I know that x is equal to this, I can now put this in for x. So this, I'm going to substitute in for x there. And so when I do that, I get, let me double check, make sure. Yeah. So I'm going to get 0.88818 times x, which is 1.000 grams minus y. And just for the sake of all of this is in terms of grams. And so then now this is going to be plus 0.79885 0.9885 times y. That's going to be equal to 0.8390 grams. So now I have to kind of multiply this through. I got to distribute this through both of these. So I got to multiply this by this and this. So I'm going to multiply 0.88818 times 1, and then 0.88818 excuse me, times negative y, or times the negative y. And so when I do that, I'm going to get 0.88818. When I multiply these together, I got to pay attention to sig figs. So here I have 4 sig figs, here I have 5. So I have to put a line under there to let myself know that I only have 4 sig figs, but I'm going to keep the extra digit. And then this becomes negative 0.88818 y. And then this is going to be plus 0.79885y. And that's going to be equal to 0.8390 grams. Okay. So now I'm going to add the y terms together, and I'm going to bring this over here, right? So I'm going to basically put terms together. So the y terms are going to come together, and I'm going to subtract this from there. So when I put these together, I get, let's see, 0.089. So I'm going to 0.08932y. And I'm going to basically subtract this from both sides. So I subtract 0.88818 on this side. So that's going to cancel out. And then I subtract 0.88818 from this side. And let me make sure I got this right. Okay. And then, yeah, so what I got here is 0049. And by the way, this should be negative, right? So this is a larger number, so that should be negative. And then, so this is going to be equal to negative. When I subtract that, that's going to be negative. So it's going to be 0.04, did I say 45? 4918. 4918. And so now all I need to do is to solve for y, divide both sides by negative 0.08932. And that's going to be divided by negative 0.08932. The negatives are going to cancel out. That's going to be put positive. And so when I do that calculation, I get y is equal to 0.5506, 0.5506. I have another digit there, 0.4 grams. And again, of course, I should only have 4 sig figs, so 1, 2, 3, 4, so I would cut it off there. And then to get x, I just subtract y from x, or y from 1, right? Because remember, the equation I have is x is equal to 1 minus 1.000 grams minus y. Well, this is y, so I subtract this from 1 and I get x. So then x is equal to 1.000 minus y. And this is y, so minus 0.550604. And that becomes what I get, 0.4493, 0.449395 grams. And remember, X is our copper 1 oxide, which is what they're asking for. What is the mass of the copper 1 oxide that was in the original 1.00 gram sample? And here it is. So we can round that to 3 sig figs. And so here, that's going to be 0.449 grams. So that's the number of grams that was in the original sample. And we're limiting that to 3 decimal places because we had 3 decimal places. And when you're subtracting, the rule is that your answer should be have the same number of decimal places at the least number of decimal places. And since we have 3 here, that would be 3 there. And that, ladies and gentlemen, is how you solve this type of problem. And I hope this was helpful. If this was helpful in any way, if you enjoyed this video, then please, by all means, like the video, share the video, hit that like button over there somewhere. Make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you need help with, put that down below. If you have a topic you want me to cover, put that down below. I would love to help you with these things. Thanks for joining me and have a great day.